Hi Sec 3s, I'll be going through your acids and bases worksheet 2 today. I will not go through questions 1 to 3 in detail because the answers can be found in your acids and bases notes. Now let's move on to questions 4 to 6. Questions 4 and 5 requires you to have a good understanding of salt solubilities. So if you have memorized your salt solubilities well, you should be able to answer these two questions with no problems. We should know that all spar salts are soluble, and spar here refers to sodium, potassium, and ammonium. So with this, we can actually eliminate option C and option D. Now this gives us with calcium hydroxide and copper 2 oxide left. Calcium hydroxide is sparingly soluble, but copper 2 oxide is completely insoluble in water. Hence the answer to question 4 is option B. Next, let's move on to question 5. Question 5 also requires you to have a good understanding of salt solubilities. For option A, calcium carbonate, all carbonates are insoluble except for your spar carbonates. So we can eliminate option A. For option B, all hydroxides are insoluble except for group 1 and some group 2 metals. And since copper 2 hydroxide is not from group 1 or group 2, we can just also eliminate option B. Next, all chlorides are soluble except for silver and lead 2 chloride. So similarly, option C is also out. This gives us left with option D for sodium hydroxide. So sodium hydroxide is soluble in water because the sodium is from group 1 and all group 1 metals are soluble. Similarly, sodium hydroxide is able to ionize completely in water to form Na plus and OH minus ion. And this OH minus ion is responsible for giving the alkalinity of the solution and is able to form an alkaline solution with pH greater than 7. Hence, the answer to question 5 is D. So lastly, let's look at question 6. Which of the following compounds is a base? The definition of a base is that a base is any metal, oxides, or hydroxides. Hence, from the 4 options, we can only choose option D, which fulfills this definition of a base. Now let's move on to question 7, where you are required to fill this flowchart. So let's look at the sulfuric acid portion first. A sulfuric acid contains these two ions, H plus and SO4 2 minus. So the formula of the acid form should be H2SO4. And the symbol for the ion that causes this acidity is a H plus ion. Sulfuric acid is also a strong acid that is able to completely ionize in water. Hence the pH should be at a very low range of 0 to 1. Next, let's look at sodium hydroxide solution. So the sodium hydroxide contains the Na plus ion and the OH minus ion. Therefore, the formula of alkali form is NaOH. And the symbol for the ion that causes this alkalinity is the OH minus ion. The approximate pH of this alkali should be in the high range because sodium hydroxide is able to ionize completely in water to form a very strong base solution. So the reaction between sulfuric acid and sodium hydroxide should be able to give you the name of this salt, sodium sulfate. So now let's move on to question 8, where you are required to write the chemical name and chemical formula of the salt form between the reaction of two reactants. So for calcium hydroxide and nitric acid, you should be able to deduce that the salt form is calcium nitrate. And calcium nitrate, the ions responsible for calcium nitrate is Ca2 plus and NO3 minus. And for a compound, the charge should be neutral. So therefore, you will need 2 NO3 minus ion to balance the charge of the Ca2 plus ion. Therefore, it's a Ca bracket NO3 bracket 2. Next, the reaction between aqueous ammonia and sulfuric acid will form the salt ammonium sulfate. So similarly, you will require 2 ammonium ion to balance the charge of the SO4 2 minus ion, the sulfate ion. Therefore, the chemical formula is bracket NaH4 2 and SO4. The reaction between ammonium chloride and calcium hydroxide will form the salt calcium chloride. Then again, Ca2 plus and Cl minus, you should be able to deduce that the chemical formula is CaCl2. Ammonium carbonate will also react with sodium hydroxide to form the sodium carbonate salt. And then again, the 2 ions that are responsible are Na plus and CO3 2 minus. Therefore, you will form sodium carbonate Na2CO3. So now let's move on to question 9. Question 9 is asking you for the chemical formula of sulfuric acid and sodium hydroxide, which we have already established earlier, H2SO4 and NaOH. So what happens when sulfuric acid reacts with ammonium carbonate? So this is actually your typical acid carbonate reaction. So as we know, acid reacts with carbonate to form a salt, carbon dioxide and water. So for the answer, one product of the reaction with ammonium carbonate, you can actually give carbon dioxide or water. Both are correct. Next, let's look at the reaction between ammonium carbonate and sodium hydroxide. So this is your typical alkali plus ammonium salt reaction. And because of this, it will form a salt, ammonia gas, and water. So other than the salt ammonium carbonate, you can actually just give the 2 other byproducts, which is ammonium gas and water. Next, let's look at question 10. So question 10 is asking you to deduce the identity of solution X. So now, when we look at question 10, it is a mixture of solution X and aqueous ammonium chloride. And because of this, ammonia gas is produced. So now we are trying to deduce what it is, right? So as we know, an alkali is able to react with ammonium salt to form salt, ammonia, and water. So therefore, in this question, you can eliminate option C and D. It must be it must be an alkali. So dilute sulfuric acid is an acid. So as we know, ammonia gas is also alkaline in nature. So it will actually turn red litmus paper blue, or blue litmus paper will remain blue. So therefore, the only correct option here is option A. The answer to question 10 is option A. So now, let's move on to question 11, where most of you seem to struggle in this question. So I guess I'll do the balancing of equation together with all of you. Most of you have no problems with the word equation. However, you guys have issues with the chemical formula of the salt, and also for writing your chemical equations. So I'll just do it together with all of you. So now, calcium hydroxide reacts with hydrochloric acid. So this is actually a typical acid-base reaction. And the salt form should be calcium chloride and water. So the calcium ion is a Ca2 plus ion, and the chloride ion is Cl minus. So the salt form will actually be CaCl2, as the salt needs to be electrically neutral. And for water, the chemical formula of water is just H2O. So now let's just write the chemical formula of calcium hydroxide of all the reactants and products. Okay. So here, let's write calcium hydroxide. This is hydrochloric acid. This is your salt, and this is water. So now, what should the state symbols be in this equation? So from here we see calcium hydroxide solution. So maybe you can highlight this solution. Solution, okay, when we mention of a solution in chemistry, solution actually contains water. So with that in mind, right, whenever you see solution, you can just write the state symbol as aqueous. Hydrochloric acid is also in the aqueous state. And calcium chloride, all chlorides are soluble except for silver and lead-2 chloride. So then again, it's also aqueous here. And for water, the state symbol should be just liquid. So let's just put liquid. Alright, so now we have already settled the chemical formula of all the products and reactants and also the state symbols. So now let's proceed to balance this equation. So now, maybe let's first try to balance the Ca atom. So here we have one Ca. So Ca is already balanced. Now let's look at another element that is also easier to balance. Maybe let's now look at Cl2. You realize that on the right hand side there's two Cl atoms, while on the left hand side there's only one Cl atom. So in order to balance this, we put a 2 in front here to balance the Cl. So now, how many H and O atoms do we have on the left side? So now we have a 2H plus a 2H and 2O on the hydroxide ion. So we have a 2H plus a 2H here, and we have a 2O. So this gives us 4H and 2O. And on the right side, you actually have H2O. So H2O is actually just 2 times of H2 and O to give 4H and 2O. So therefore, we just put a 2 here. And then now let's erase whatever that we don't need. So this should be your fully balanced chemical equation for 11A. Okay, so now let's move on to part B. Again, part B is your acid-base reaction, where sodium hydroxide reacts with sulfuric acid to form a salt and water. So I think most of you can deduce that the salt form is sodium sulfate with the Na plus and the SO4 2 minus ions. So in order for Na plus to balance the charge of SO4 2 minus, you require 2 Na plus ions. So therefore, the salt form should actually have this chemical formula, Na2SO4. And then for water, we will just use H2O. So now let's write out all the chemical formula of the products and reactants first. So NaOH is state symbol plus H2SO4 give you Na2SO4 plus H2O. So now let's insert our state symbols first. NaOH, as we know, it should be an aqueous. It's a soluble hydroxide with acid, aqueous as well. All sulfates are soluble except for barium, calcium, and lead-2 sulfate. So then again, you'll form the Na2SO, the sodium sulfate solution. And for H2O, the state symbol of H2O should just be L. Alright, so now let's balance the equations together. Maybe let's look at Na first, because Na should be the one that is easier to balance. So as you can see, there's 2 Na on the right hand side. So in order to balance this on your left hand side, right, NaOH, you have to require to put a 2 in front here. Then maybe let's try to balance. The next thing that's easier to balance is your SO4 ion. So I don't want you guys to actually expand out SO4 and count all the SO4 ion together. Rather, I feel that for your SO4 ion, try to treat your SO4 ion as X. So here you are given H2X. And your SO4 ion here, right, you just treat it as 1X. So as you can see, the X on both sides are balanced. There's 1X on left hand side, 1X on right hand side. So now let's try to settle the H and the O atoms left. So now let's count how many H and O atoms we have left. So here we will have 2O and 2H atoms. Whereas for H2SO4, you're left with 2H atoms. So with a total, you should have 4H and 2O. So to balance this on your right hand side, you can just simply put a 2 in front here of the H2O. So with this, we can see that the for the equation in part B is fully balanced. Okay, now let's move on to question C. Sodium hydroxide plus ammonium chloride. So alkali plus an ammonium salt. You should be able to get a salt, a gas, and an ammonia gas and water. So similarly, I think you guys should be able to deduce the chemical formula of the products and reactants. So let's just write them out first. Let's just write NaOH. And for ammonium chloride, the ions responsible are the NH4 plus ammonium ion and the Cl minus chloride ion. So it will just be NH4Cl. Then again, with your bracket state symbols. And the salt form should be NaCl. Plus ammonia gas. Ammonia gas is NH3, okay? Okay, sorry. And plus your water. Okay, so now let's try to balance this equation. Let's balance Na first. We have one Na on the left hand side, one Na on the right hand side. So for now, Na is balanced. Next, let's look at Cl. So Cl is also balanced. One Cl on the left, one Cl on the right. So now let's try to look at the ammonium ion right here. So ammonium ion is actually NH4. But actually NH4, you can also write it as something like this. NH3 plus H. So you can break it up into NH3 plus H. So with that in mind, as you can see, the NH3 here actually just completely transfer over from the left hand side and the right hand side, right? There's actually one NH3 each already. So now you are left with one H, right, from NH4Cl, left with this one H atom, and then you are left with this OH atom. So O and H plus H, it can give you H2O. So because of this, right, actually this equation is already balanced as it is. So maybe at the end we just insert your state symbols. NaOH equals all ammonium salts are soluble, so equals all chlorides are soluble except for silver and lead 2, so equals as well. NH3 is your ammonia gas, so G. H2O is your liquid, so it's an L. So this is your correct answer. NaOH plus NH4Cl, NaCl plus NH3 plus H2O, and all the coefficients are 1. So lastly, let's move on to part D. So part D, you are given potassium hydroxide plus ammonium sulfate. Then again, this is your alkali plus ammonium salt reaction. So the salt form should be potassium sulfate, and the two byproducts are your ammonia gas and water. So similarly, now let's try to write all the chemical formulas of the products and reactants. So potassium hydroxide should be KOH because of the K plus and the OH minus ion. Next, for your ammonium sulfate, the ammonium ion is NH4 plus and sulfate ion is SO42 minus. So to balance these two ions out, you require two NH4 ammonium ions and SO4. So K plus and SO42 minus similarly, K2SO4. And plus your ammonium gas, ammonia gas, and your water. Okay, so I think the easiest things to balance right now are actually your K atoms, and also for your ammonium ion. So these two will be the easiest to balance. So let's try to maybe balance K first. Alright, K, 1 on the left side, 2 on the right side. So how do you balance? You put the 2 in front of your KOH. Okay, so now K is settled. Now let's look at our N atoms. So here, as you can see, there's 1 unit of NH3. And remember, in the previous question, I said that NH4, you can treat it like NH3 plus H. However, now do take note, there's a coefficient of 2. Coefficient of 2 here. So it's actually 2 NH3 plus H. So by right, you should be able to form 2 NH3 and 2 H. And 2 H atoms spare remaining. So for NH3 here, to balance the 2 NH3 on the left side, here we just put a 2. Okay. However, now we are left with 2H remaining. Okay, this one just take note, we have 2H atoms remaining here. Now maybe let's look at SO4. Remember SO4, I say you can treat it like something like an X. Just group the whole SO4 poly anion together as an X. So then again you have 1X, and on the right hand side you got 1X. So SO4 is already balanced. Now we remember we have previously established that there is 2H remaining when we for NH4. However, for here we also have 2 O's and 2H remaining. So total, when both of these add together, you have 2O, 4H remaining. So how do we balance the H2O? It's simply we just put a 2 here. So now K is balanced, SO4 balanced, NH3 also balanced, H2 also balanced. So in total, the complete equation should be like this. Okay, so this is already balanced. Now let's just insert the state symbols at the end. KOH is soluble. Ammonium salts are all soluble. Potassium salts are also all soluble. And ammonia gas is gas, and this is liquid. So therefore, this is your answer for 11D.